Hello everyone, I'm Mark Nelson. I want to welcome you to National Cement of Alabama's longtime Ragland operation. Today, we're excited to show off our 2-year, $300 million expansion project. A project to incorporate the latest cement-making technology, reduce our carbon footprint, and become the most efficient cement operation in the United States. This expansion is designed to increase our capacity and play a key role in reaching the Vicat Group's aggressive carbon emission targets. The new kiln line features the very latest in cement production technology. First up, a few quick numbers. Building this massive operation required about 450 mechanical and electrical workers, about 260,000 work hours to complete. Besides tons of structural steel and steel plates, this production line required 21,000 yards of concrete alone. That material was supplied by the central division of our sister company, Kirkpatrick Concrete. So let's jump right in and take you to the very first step on our tour, the vertical raw mill. Now, this piece of equipment carries out a vital function in the production of cement. It dries and grinds our locally sourced raw materials into a raw meal. That's a kind of very fine powder that we later convey to this 256-foot high blending silo for further refinement. The 4 main raw materials handled by the vertical raw mill include limestone, which is quarried nearby and carried by a 2.6-mile conveyor to our storage barn. Clay, which we gather from our property or from outside sources within a 40-mile radius of here. Mill scale, a recycled iron material from Birmingham area steel operations, and a special type of industrial sand mined right here in Alabama for specific silica properties. Inside this housing, you'll find 4 grinding rollers. That's the big object on the left, and a turning table on the bottom. These components subject the raw materials to extreme pressure, some 2,000 psi. Everything is set in motion by a powerful 5,500 horsepower motor with a gear unit. The vertical raw mill has a nominal output of 380 metric tons of raw meal per hour. When compared to a traditional ball mill, this equipment uses 40% less electricity and is a key component in our transition to a lower CO2 footprint. The next stage and next stop on our tour is the blending and storage silo. The blending silo is designed to efficiently and continuously mix the raw meal, ensuring a consistent, chemically stable material that's ready for processing into clinker. The tower's vertical slip-form construction kicked off in July 2020. Once it started, the process couldn't stop. It took 12 days of continuous round-the-clock concrete deliveries to complete. Here you can see just how thick the cast-in-place concrete walls are. That's 3 feet of solid concrete. Inside, an additional mixing chamber ensures a uniform, consistent material for the kiln feed. This silo is also capable of storing over 13,000 metric tons of material. Our third stop is the Preheater Tower. Now, this is one part of the new kiln line you literally can't miss. That's because from the ground to the top of the support tower is a dizzying 315 feet. And when you add this stack way on top, the final height is 440 feet. This 5-stage cyclone preheater with integral calciner and tertiary air duct is an indispensable part of Ragland's new advanced energy-efficient kiln line. It's energy efficient because this entire production line is designed to operate on 100% alternative fuels. This large U-shaped device is called an inline calciner, which gives the system a full 7 seconds to completely burn all waste. The Y-shaped pipes are known as the tertiary air duct. They return heat from the clinker cooler back into the system. We use all the heat we generate. No energy is wasted. Our fourth stop on the tour is where all of the action happens, the new 70-meter Rotary Kiln line. That's about 229 feet across. If you stood the kiln vertically, it would soar to 21 stories high. The kiln is basically a huge steel tube supported by 3 piers that rotate on these enormous roller stations. Inside, it's lined with special fire brick designed to stand up to very intense heat. Just how much heat? Try 2,700 degrees Fahrenheit. At the lower end, it's a roaring blast of flame produced by precisely controlled burning of alternative fuels. The result of that red-hot process are these gray balls known as clinker. They're the final product that is eventually ground up and made into cement. We cool the clinker down with air here. This equipment is the Polytrack Clinker Cooler. This entire system can produce 5,000 metric tons of clinker every day. Now, one of the most exciting parts of this entirely new operation comes from this ordinary-looking warehouse. It's the Alternative Fuels Facility, and it's where our shift to clean energy sources begins. Here, biomass and industrial waste are stored and used as a heat source for the cement-making process. So what kind of materials are we talking about? One is tire-derived fuel, or TDF. That's shredded up scrap tires reduced down to 1 to 3 inch rubber chips. Another alternative fuel we can use is dried sawdust or wood chips from nearby furniture manufacturers. These storage bins and reception pits are cast-in-place concrete soaring 40 feet high. Since all of these materials are highly combustible, infrared cameras continuously monitor the storage area for hot spots. If trouble is detected, sprinklers and water cannons automatically suppress any potential fire. This giant claw, known as an orange peel scrap grab, travels on an overhead crane. It moves the alternative fuels from reception pits to a hopper that convey them to the kiln's main burner. The last stop on our short tour is the new clay storage system. This large-scale, fully automated system is a more efficient, productive, and safer way to handle our bulk material. Radar sensor technology collects 3D data on the pile shape and positioning of the equipment. The clay stacker and reclaimer operate together to pre-blend the crushed material and improve its uniformity. The raw material travels on conveyor belts, and before it ever reaches the vertical raw mill, a cross-belt analyzer examines its levels of alumina and iron, as well as its ratio of calcium to silica. Well, that's our short tour. We've shown you the key parts of our new operation: the vertical roller mill, the blending silo, the preheater tower, the rotary kiln and clinker cooler, the alternative fuels facility, and finally, the automated clay storage system. There's a lot more I could tell you about, but our time is up. So on behalf of all the technicians, skilled workers, maintenance crews, and management of the National Cement Company of Alabama, we want to thank you for marking this major historic milestone with us.